NASA's Hubble Space Telescope is the first major infrared optical ultraviolet telescope to be placed into orbit around the Earth. Located high above Earth's obscuring atmosphere, the telescope has provided the clearest views of the universe yet obtained in optical astronomy. The telescope is named after the American astronomer Edwin P. Hubble, who in the 1920s found galaxies beyond our Milky Way and discovered that the universe is uniformly expanding. The heart of the telescope is the 94.5-inch diameter primary mirror. It is the smoothest optical mirror ever polished, with a surface tolerance of 1/1,000,000th of an inch. It is made of fused silica glass and weighs about 1,800 pounds. Outside the blurring effects of Earth's turbulent atmosphere, the telescope can resolve astronomical objects with an angular size of 0.05 arcseconds, which is like seeing a pair of fireflies in Tokyo from your home in New York City. This razor-sharp vision is 10 to 20 times better than typical resolution with large ground-based telescopes. The Space Telescope can detect objects as faint as 31st magnitude, which is slightly better than the sensitivity of much larger Earth-based telescopes. Because generally, the fainter an object is, the farther away it is, Hubble has been used to probe the limits of the visible universe and uncover never-before-seen objects near the horizon of the cosmos. Because it is outside our atmosphere, the telescope can view astronomical objects across a broad swath of the electromagnetic spectrum, from ultraviolet light to visible to near-infrared wavelengths. The telescope can also see faint objects near bright objects. This is an important requirement for studying the environments around stars and the glowing nuclei of active galaxies. The Hubble Space Telescope was launched April 24, 1990 by the Space Shuttle Discovery. Hubble was originally equipped with 5 science instruments: the Wide Field Planetary Camera, the Faint Object Camera, the Faint Object Spectrograph, the Goddard High-Resolution Spectrograph, and the High-Speed Photometer. In addition, 3 fine guidance sensors were used for pointing and for precision astrometry, the measure of angles on the sky. After Hubble was launched, scientists discovered that its primary mirror was misshapen due to a fabrication error. This resulted in spherical aberration, the blurring of starlight because the telescope could not bring all the light to a single focal point. Using image processing techniques, scientists were able to do significant research with Hubble until an optical repair could be developed. In December 1993, the first Hubble servicing mission carried replacement instruments and supplemental optics aboard the Space Shuttle Endeavour to restore the telescope to full optical performance. A corrective optical device called the Corrective Optics Space Telescope Axial Replacement was installed so that it could improve the sharpness of the first-generation instruments. The Wide Field and Planetary Camera was replaced with a second camera, which has a built-in correction for the aberration in the primary mirror. In February 1997, the Space Shuttle Discovery returned to Hubble for a second servicing mission. 2 advanced instruments, the Near-Infrared Camera and Multi-Object Spectrometer, and the Space Telescope Imaging Spectrograph, were swapped out with the 2 first-generation spectrographs. Astronauts also replaced or enhanced several electronic subsystems and patched unexpected tears in the telescope's shiny aluminized thermal insulation blankets, which give the telescope its distinctive foil-wrapped appearance. In December 1999, the Space Shuttle Discovery rendezvoused with Hubble for a third servicing mission. Astronauts replaced faulty gyroscopes, which had suspended science observations for nearly a month. The telescope also got a new high-tech computer and a data recorder. The astronauts left the telescope better than ever before as it prepared to continue its journey, bringing the vastness of space closer to home. Orbiting space observatories like Hubble can trace their roots to the 1920s. While most scientists considered a space telescope as pure science fiction, some were seriously exploring the idea. Rocket pioneer Hermann Oberth, for example, speculated about orbiting telescopes in his writings, and scientist Robert Goddard began testing his newly invented liquid fuel rockets. As these men were pushing the technological envelope, Edwin Hubble was unveiling new heavenly horizons. Before Hubble came along, astronomers had a restricted view of the universe, believing that the only galaxy in the heavens was our Milky Way. But Hubble used the latest technology, a powerful 100-inch telescope, and made some startling discoveries that changed our concept of the cosmos. First, he observed that galaxies exist beyond the Milky Way. Then he found that those galaxies are flying away from each other, an observation that helped him determine that the universe is expanding. It takes powerful telescopes to study the uncharted territories of the vast cosmos, but it became increasingly clear to astronomers that Earth's atmosphere distorted starlight, which made it difficult to obtain razor-sharp views of celestial objects. The idea of placing a telescope in space above Earth's turbulent air had been kicked around for several years, but scientists pondered how to transport a telescope into space. The rocket technology pioneered by Oberth and Goddard and revolutionized by the Germans during World War II became the means of transportation. After scientists figured out the means, they focused on coming up with the money to develop and build a space telescope. NASA, which was created in 1958, and well-known American astronomers such as Lyman Spitzer began championing the cause, trying to convince Congress that such a project was useful. In 1977, Congress finally agreed to allocate the money, but it took a decade of research, planning, and testing before NASA successfully launched its first space observatory. And 2 more decades passed before NASA launched the Hubble telescope, which has expanded our heavenly vistas far more than its namesake ever dreamed. Larger earthbound telescopes can see as far as Hubble can. All telescopes are essentially time machines. Probing the secrets of deep space means looking farther back in time. That's because light from faraway galaxies takes millions to billions of years to reach Earth, providing astronomers with a record of how those objects appeared long ago. But the eye in space has sharper vision because of its superior location. At 368 miles above our planet, the orbiting observatory is outside Earth's turbulent blanket of air that makes star images wiggle. Other orbiting observatories have probed the secrets of space, but Hubble is the largest and most versatile. Its visible light camera, called the Wide Field and Planetary Camera 2, has consistently delivered stunning images of celestial objects, including the pillars of dust and gas that harbor nascent stars, and the colorful death shrouds of aging sun-like stars. The visible light camera isn't Hubble's only source of celestial revenue. The telescope has a fleet of other science instruments that covers a broad range of light, from ultraviolet to near-infrared. These instruments allow Hubble to probe a galaxy's hottest stars and to peer far across space to study the evolution of galaxies. With Hubble's help, astronomers have monitored weather patterns on our solar system planets and harvested important information about stars and galaxies. Regular maintenance visits to the telescope keep the steady stream of pictures rolling off the Hubble assembly line. In fact, NASA designed the telescope for servicing in space. Earthbound telescopes receive routine checkups to ensure they're functioning properly. They also receive regular upgrades when new advances in technology come around. Hubble is no different. That's why astronauts visit the telescope every few years, replacing older equipment and adding state-of-the-art science instruments. Future servicing missions are planned for 2001 and 2003. In 2001, astronauts will install the Advanced Camera for Surveys, which will capture an even wider swath of the sky and will yield even sharper pictures than Hubble's current wide-field camera. In the first 10 years since its creation, The Hubble Space Telescope has not only had a profound impact on astronomical research, but it has brought a glimpse of the wonders of the universe into millions of homes worldwide. This has inspired an unprecedented public curiosity. It will be important to keep the detectors and telescope Earth and solar system were born 4.5 billion years ago. Clues to our genesis are fragmentary, so astronomers must look at the birth of stars in neighboring stellar maternity wards to see a replay of the events that created our sun and planets. By studying debris disks composed of dust and gas whirling around developing stars, the NASA Hubble Space Telescope's high resolution has opened up a new level of detail that reinforces earlier theories and offers some new surprises about planet birth. The ultimate goal, which only may be realized by a next-generation space telescope, will be to inventory planets and solar systems around other stars and ultimately identify Earth-like planets. Hubble captured thousands of gaseous knots from a doomed star in the Helix Nebula, the closest planetary nebula to Earth, 450 light-years away in the constellation Aquarius. Each gaseous head is at least twice the size of our solar system. Each tail stretches 100 billion miles, about 1,000 times the Earth's distance to the Sun. The comet-like tails form a radial pattern around the star, like the spokes on a wagon wheel. Astronomers have seen the spoke pattern using ground-based telescopes, but Hubble reveals for the first time the sources of these objects. The Keyhole Nebula, named in the 19th century by Sir John Herschel, is located adjacent to the famous explosive variable star Eta Carinae. The pronounced pillars and knobs of the upper left cloud appear to point toward a luminous massive star, which may be responsible for illuminating and sculpting them by means of its high-energy radiation and stellar wind of high-velocity ejected material. The circular keyhole structure contains both bright filaments of hot fluorescing gas and dark silhouetted clouds of cold molecules and dust, all of which are in rapid chaotic motion. The high resolution of the Hubble images reveals the relative three-dimensional locations of many of these features, as well as showing numerous small dark globules that may be in the process of collapsing to form new stars. At a distance of 7,100 light-years from Earth, the Bubble Nebula is by Immanuel Kant to explain the simple fact that all the planets of the solar system lie in nearly the same plane, and so were born from a primordial disk that provided the raw material for planet growth. The Hubble images may long be remembered as the first tantalizing visual evidence that planets might be ubiquitous in the galaxy. Dozens of stars in the Orion region, which itself is just one of thousands of starbirth regions in the Milky Way galaxy, have these disks. Though it is not clear if they will go on to condense into planetary systems, their abundance alone is firm visual evidence that the first baby steps toward planet formation are very common. The Hubble telescope has also spied these disks around isolated young stars, ranging in age from 1 million to 10 million years. Astronomers have used the Hubble's arsenal of cameras to capture these disks in ultraviolet to near-infrared light. By chronicling these disks at different stages of a star's early life, astronomers are adding information to the planet-making recipe. Images taken in infrared and visible light by Hubble recount a vivid story of the turbulent birthing process of massive stars. Powerful radiation and high-speed material unleashed by hefty adult stars residing in the hub of the 30 Doradus Nebula are triggering a new burst of star birth in the surrounding suburbs. Like their adult relatives, the fledgling stars are creating all sorts of havoc in their environment. Nascent stars embedded in columns of gas and dust are blowing away the tops of their nurseries, like a volcano blasting material into the sky. Jets of material streaming from another developing star are slamming into surrounding dust and gas in opposite directions, causing it to glow in moving patterns. The giant galactic nebula NGC 3603 displays various stages of the life cycle of stars in one single view. To the upper left is the evolved blue supergiant Cher 25. The grayish-blue color of the ring and the bipolar outflows indicate the presence of chemically enriched material. Below Cher 25 is a starburst cluster dominated by young, hot Wolf-Rayet stars and early O-type stars. Hubble's unique capabilities have been utilized to identify 3 separate populations in this concentration of nearly 10,000 stars. About 60% of the stars belong to the dominant yellow cluster called NGC 1850, which is estimated to be 50 million years old. A few white massive stars are only about 4 million years old and represent about 20% of the stars in the image. The significant difference between the 2 cluster ages suggests these are 2 separate star groups that lie along the same line of sight. Penetrating 25,000 light-years of obscuring dust in myriad stars, Hubble has provided the clearest view yet of the 4-million-year-old quintuplet cluster. It has stars on the verge of blowing up as supernovae and is the home of the Pistol Star, the brightest star seen in the galaxy. NGC 4881 is an elliptical galaxy in the outskirts of the Coma cluster, a great cluster of galaxies more than 5 times farther away than the Virgo cluster. Except for a Coma spiral at the right and a few foreground stars of the Milky Way, nearly everything else in this image lies far beyond the Coma cluster. There is a fascinating assortment of background galaxies, including an apparent Galaxian merger in progress. The distance to the Coma cluster is an important cosmic yardstick for scaling the overall size of the universe. The starlight harvested from remote objects began its journey toward Earth billions of years ago. The further Hubble looks into space, the further it looks back into time. Hubble has seen back to a time when the universe was only about 5% of its present age. These long exposures of the universe have revealed galaxies that existed when the universe was less than 1 billion years old. Some of the objects viewed were so dim that seeing them would be as difficult as discerning a flashlight on the moon as seen from Earth. This stellar swarm is M80, one of the densest of the 147 known globular star structures in the Milky Way galaxy. Located about 28,000 light-years from Earth, M80 contains hundreds of thousands of stars, all held together by their mutual gravitational attraction. Globular clusters are particularly useful for studying stellar evolution, since all of the stars in the cluster have the same age, but cover a range of stellar masses. Every star visible in this image is either more highly evolved than, or in a few rare cases, more massive than our own Sun. Especially obvious are the slowly dying bright red giants, which are stars similar to the Sun in mass. NGC 1808 is called a barred spiral galaxy because of the straight lines of star formation on both sides of the bright nucleus. This star formation may have been triggered by the rotation of the bar or by matter which is streaming along the bar towards the central region. Filaments of dust are being ejected from the core into a faint halo of stars surrounding the galaxy's disk by massive stars that have exploded as supernovae in the starburst region. Astronomers used NASA's Hubble Space Telescope to look out into the universe over distances exceeding 12 billion light-years. These deepest views of the heavens, made with Hubble's visible and infrared cameras, are collectively called the Hubble Deep Field, which has uncovered more than 1,000 galaxies in a patch of sky no larger than a grain of sand held at arm's length. Stretched out across the entire sky, this means the universe contains at least 120 billion galaxies at various stages of evolution, strung along a corridor of billions of light-years. The Able 221 cluster has an enormous gravitational field that deflects light rays passing through it, much as an optical lens bends light to form an image. This phenomenon, called gravitational lensing, magnifies, brightens, and distorts images from faraway objects. The cluster's magnifying powers provide a zoom lens for viewing distant galaxies that could not normally be observed with the largest telescopes. This useful phenomenon has produced the arc-shaped patterns found throughout the Hubble image. These arcs are the distorted images of very distant galaxies which lie 5 to 10 times farther than the lensing cluster. Through gravitational lensing, these remote objects are magnified, enabling scientists to study them in more detail. This analysis provides a direct glimpse of how star-forming regions are distributed in remote galaxies and yields other clues to the early evolution of galaxies. NGC 4650A is one of only 100 known polar ring galaxies. Its unusual disk ring structure is not yet understood fully. One possibility is that the polar rings are the remnants of a colossal collision between two galaxies sometime in the distant past, probably at least 1 billion years ago. In the direction of the constellation Canis Major, two spiral galaxies pass by each other like majestic ships in the night. The larger and more massive galaxy is NGC 2207, and the smaller one is IC 2163. Strong tidal forces from NGC 2207 have distorted the shape of IC 2163, flinging out stars and gas into long streamers stretching out 100,000 light-years. Trapped in their mutual orbit around each other, these two galaxies will continue to distort and disrupt each other. Eventually, billions of years from now, they will merge into a single, more massive galaxy. It is believed that many present-day galaxies, including the Milky Way, were assembled from a similar process of coalescence of smaller galaxies occurring over billions of years. Located some 13 million light-years from Earth, NGC 4214 is currently forming clusters of new stars from its interstellar gas and dust. In this Hubble image, we can see a sequence of steps in the formation and evolution of stars and star clusters. Clusters of young bright blue stars highlight NGC 4603's spiral arms. In contrast, red giant stars in the process of dying are also found. Only the very brightest stars in NGC 4603 can be seen individually, even with the unmatched ability of the Hubble Space Telescope to obtain detailed images of distant objects. Much of the diffuse glow comes from the fainter stars that cannot be individually distinguished by Hubble. The reddish filaments are regions where clouds of dust obscure blue light from the stars behind them. Hubble images of NGC 4414 show that the central regions of this galaxy, as is typical of most spirals, contain primarily older yellow and red stars. The outer spiral arms are considerably bluer due to ongoing formation of young blue stars, the brightest of which can be seen individually at the high resolution provided by the Hubble camera. The arms are also very rich in clouds of interstellar dust seen as dark patches and streaks silhouetted against the starlight. Based on careful brightness measurements of variable stars in NGC 4414, astronomers were able to determine that it is about 60 million light-years away from Earth. In the 1920s, astronomer Edwin Hubble discovered that galaxies are all moving away from us at a rate proportional to their distance. The farther away a galaxy is, the faster it appears to be traveling. This relationship, called the Hubble constant, establishes an expansion rate that is critical for estimating the age and size of the universe. The universe is expanding because it was born in a fiery explosion, called the Big Bang, many billions of years ago. The quest to precisely determine the Hubble constant was headed by the Key Project team, a group of astronomers who used NASA's Hubble Space Telescope to look far away for accurate milepost markers, a special class of stars called Cepheid variables. The rhythmic pulsations of these aged bright stars yields their intrinsic brightness, which in turn is needed to measure precise distances. Hubble's clear vision has allowed astronomers to accomplish in a few years Cepheid observations that previously required decades of painstaking work with ground-based telescopes. Astronomers used Hubble to systematically search for Cepheids in our galactic neighborhood out to the distance of the Virgo cluster of galaxies. Cepheids were used to calibrate even more remote markers, such as supernovae, which are so bright they can be seen billions of light-years away. The Hubble Constant Key Project team found that the universe is between 12 and 14 billion years old, depending on the density of matter in space. Hubble played an important role in the discovery that the expanding universe may actually be accelerating. In other words, the galaxies are rushing away from each other ever faster as time goes on. Hubble observations of distant supernovae were used to measure how quickly the universe was expanding long ago. Astronomers were surprised to discover that the universe was actually expanding at a slower rate billions of years ago. This implies that there may be a mysterious force, an anti-gravity, that pushes galaxies apart at an increasingly faster rate the farther away they are from each other. This means the universe may continue expanding forever and never collapse in a fiery Big Crunch. In the violent environment of colliding galaxies, Hubble showed that young, massive, compact star clusters are formed when two galaxies collide or interact strongly. The formation time is of the order of 10 million years or less, and these clusters may be the progenitors of globular clusters. Hubble has unveiled a variety of shapes, structures, and fireworks that accompany the birth and death of stars. Hubble images of newly forming stars reveal blowtorch-like jets of hot gas streaming from deep within the disks around the stars. Possibly shaped into long, slender streamers by magnetic fields, these jets are an exhaust product of star formation. They travel across space for billions of miles before slamming into material in the star's vicinity. In dramatic images, Hubble has shown the effects of very massive young stars on their surrounding nebulae. With the astronomical equivalent of a hurricane, The intense flow of visible and ultraviolet radiation from an exceptionally massive young star eats into surrounding clouds of cold hydrogen gas laced with dust. This helps trigger a firestorm of star birth in the neighborhood around the star. Hubble has produced a dazzling array of images of colorful shells of gas blasted into space by dying stars. These intricate structures are fossil evidence, showing that the final stages of stars' lives are more complex than once thought. An aging star sheds its outer layers of gas through stellar winds. Late in a star's life, these winds become more like a gale and consequently sculpt striking complex shapes. When massive stars die, they don't die as quietly as lighter-weight stars. They end their lives with mammoth explosions. Hubble has been keeping an eye on one such nearby explosion, supernova 1987A. The star's self-destruction was first seen on February 23, 1987 by a ground-based telescope. In July 1997, the Hubble telescope's imaging spectrograph captured the first images of material ejected by the exploding star ramming into an inner ring around the dying object. Shocked by the 40 million mile per hour sledgehammer blow, a 100 billion mile wide knot of gas in a piece of the ring has already begun to light up as its temperature surges from a few thousand degrees to 1,000,000 degrees Fahrenheit. By analyzing this glowing ring, astronomers may find clues to the final years of the doomed star's existence. These 18 young galaxies, or galactic building blocks, contain dust, gas, and a few billion stars. Each of these objects is 11 billion light-years from Earth, and much smaller than today's galaxies. At this distance, the universe was only about 16% of its current age. These galaxies were found within an area about 2 million light-years across, which is about the distance between our Milky Way and the Andromeda Galaxy. Some astronomers believe the young objects are the ancient building blocks of today's galaxies because they are close enough in space to eventually collide or merge with each other. The Hubble Deep Field was assembled from 342 separate exposures taken with the Wide Field and Planetary Camera 2 for 10 consecutive days between December 18th and 28th, 1995. Representing a narrow keyhole view stretching to the visible horizon of the universe, the Hubble Deep Field image covers a speck of the sky, only about the width of a dime, located 75 feet away. Though the field is a very small sample of the heavens, it is considered representative of the typical distribution of galaxies in space, because the universe, statistically, looks largely the same in all directions. Gazing into this small field, Hubble uncovered a bewildering assortment of at least 1,500 galaxies at various stages of evolution. Most of the galaxies are so faint even the largest telescopes have never seen them. Some of the galaxies in this menagerie probably date back to nearly the beginning of the universe. The astronomical term deep means looking at the faintest objects in the universe. Because the most distant objects are also among the dimmest, the image is the equivalent of using a time machine to look into the past to witness the early formation of galaxies, perhaps less than 1 billion years after the universe's birth in the Big Bang. Staring at one spot in the sky for 10 days, Hubble kept taking pictures one after another for the entire exposure time, accumulating data. Each exposure was typically 15 to 40 minutes long. Separate images were taken in ultraviolet, blue, red, and infrared light. By combining these separate images into a single color picture, astronomers will be able to infer the distances, ages, and composition of the galaxies in the Hubble Deep Field image. Astronomers at the Space Telescope Science Institute processed the frames, removing cosmic rays and other artifacts, and put them together into one final picture. Each time they added a picture, the view got deeper, revealing fainter objects. When they were done, they had the deepest picture ever taken of the heavens. The Hubble Deep Field South, taken in 1998, is in the constellation Tucana, near the south celestial pole. This series of images complements the original Hubble Deep Field taken in late 1995, when Hubble was aimed in the opposite direction of the sky, near a small patch of space near the Big Dipper. The two fields now give astronomers two core samples of the universe for better understanding the history of the cosmos. The pair of observations can be compared to more confidently define the state of the cosmos as a whole. It would take astronomers 900,000 years to use Hubble to survey the entire sky to the depths of the Hubble Deep Field. So they must rely on a thin looking through a soda straw view across the cosmos and infer the history of star and galaxy formation. Hubble's Variable Nebula, named after Edwin P. Hubble, is a fan-shaped cloud of gas and dust illuminated by a bright star at the bottom. The star itself, lying about 2,500 light-years from Earth, cannot be seen directly, but only through light scattered off of dust particles in the surrounding nebula. Dense condensations of dust near the star cast shadows out into the nebula, and as they move, the illumination changes, giving rise to the variations first noted by Hubble. A supermassive black hole residing in the hub of the nearby galaxy NGC 4438 appears to be blowing huge bubbles of hot gas into space. Known as a peculiar galaxy because of its unusual shape, NGC 4438 is in the Virgo cluster, 50 million light-years from Earth. This Hubble image of the galaxy's central region clearly shows one of the bubbles rising from a dark band of dust. The other bubble, emanating from below the dust band, is barely visible. Hubble captured the sharpest view yet of the Ring Nebula. Hubble looked down a barrel of gas cast off by a dying star thousands of years ago. This image reveals elongated dark clumps of material embedded in the gas at the edge of the nebula, the dying central star floating in a blue haze of hot gas. The Ring Nebula is about a light-year in diameter and is located some 2,000 light-years from Earth, in the direction of the constellation Lyra. A pair of 1/2 light-year long interstellar twisters, eerie funnels and twisted rope structures in the heart of the Lagoon Nebula, are 5,000 light-years away in the direction of the constellation Sagittarius. The central hot O-type star, Herschel 36, is the primary source of the ionizing radiation for the brightest region in the nebula called the hourglass. Other hot stars also present in the nebula are ionizing the extended optical nebulosity. The ionizing radiation induces photoevaporation of the surfaces of the clouds, seen as a blue mist, and drives away violent stellar winds tearing into the cool clouds. Many of the stars in Hodge 301 are so old that they have exploded as supernovae. These exploded stars are blasting material out into the surrounding region at speeds of almost 200 miles per second, plowing into the surrounding Tarantula Nebula, shocking and compressing the gas into a multitude of sheets and filaments. Also present near the center of the image are small, dense gas globules and dust columns, where new stars are being formed today as part of the overall ongoing star formation throughout the Tarantula region. At the center of the Crab Nebula lies the Crab Pulsar, the collapsed core of an exploded star. The Crab Pulsar is a rapidly rotating neutron star, an object only about 6 miles across, but containing more mass than our Sun. As it rotates at a rate of 30 times per second, The Crab pulsar's powerful magnetic field sweeps around accelerating particles and whipping them out into the nebula at speeds close to that of light. NGC 2346 is remarkable because its central star is known to be actually a very close pair of stars orbiting each other every 16 days. When one component of the binary evolved, expanded in size, and became a red giant star, it literally swallowed its companion star. The companion star then spiraled downwards inside the red giant, and in the process spewed out gas into a ring around the binary system. Later on, when the hot core of the red giant was exposed, it developed a faster stellar wind, which emerged perpendicularly to the ring and inflated two huge bubbles. HH32 is a Herbig-Haro object which is formed when young stars eject jets of material back into interstellar space. HH32 is somewhat older than Hubble's Variable Nebula, and the wind from the bright central star has already cleared much of the dust out of the central region, thus exposing the star to direct view. NGC 6543, also known as the Cat's Eye Nebula, is one of the most complex planetary nebulae ever seen. The Cat's Eye Nebula has surprisingly intricate structures, including concentric gas shells, jets of high-speed gas, and unusual shock-induced knots of gas. Estimated to be 1,000 years old, the nebula is a visual fossil record of the dynamics and late evolution of a dying star. NGC 3132 is an expanding cloud of gas surrounding a dying star. Also called 8-burst or the Southern Ring Nebula, it is nearly half a light-year in diameter. At a distance of about 2,000 light-years from Earth, it is one of the nearest known planetary nebulae. For nearly a decade, Hubble has monitored the weather on Mars, and observations in the spring and summer of 1997 provided detailed reports to help plan the landing of NASA's Mars Pathfinder and the arrival of Mars Global Surveyor. Pictures taken about a week before the landing of the Pathfinder spacecraft show a dust storm churning through the deep canyons of Valles Marineris, just 600 miles south of the landing site. Hubble snapped an image on April 27, 1999, of an enormous cyclonic storm system raking the northern polar regions of Mars. Nearly 4 times the size of the state of Texas, the storm is composed of water ice clouds like storm systems on Earth, rather than the dust typically found in Martian storms. Hubble observations of Mars between April 27 and May 6, 1999, were used to create this time-lapse animation of one full rotation of the planet. This animation shows Mars in the middle of northern summer, when the planet was about 54 million miles from Earth. Surface features as small as 12 miles across are visible, including numerous craters, the North Polar Cap, surrounded by a ring of dark sand dunes, cloud-shrouded volcanoes, widespread bluish-white water ice clouds, and a massive cyclonic storm churning near the polar cap. In 1994, Hubble caught an invasion of Jupiter when 21 fragments of comet Shoemaker-Levy 9 slammed into the planet. As each comet fragment crashed into the giant planet, Hubble imaged mushroom-shaped plumes along the edge of the planet. The largest fragment impact created an Earth-sized bullseye pattern on Jupiter. The high-resolution images provided exquisite details on the plume's geometry, on the growth and dispersion of the impact features, and on atmospheric waves expanding around the impact sites. The precise nature of these waves is still the subject of some debate. Thus, this is a case where by unveiling more details, the simple can become complex. A comet impact is a relatively rare phenomenon. 1,000 years may pass before a similar event is observed again. Hubble's sharp images show that the fragments, the largest of which were probably a few miles across, did not break up catastrophically before plunging into Jupiter's atmosphere. This reinforces the notion that solid, massive bodies produce the comet's atmospheric explosions. Hubble telescope observations were used to make global maps of Jupiter for tracking changes in the dark debris caught up in the high-speed winds at Jupiter's cloud tops. This debris is a natural tracer of wind patterns, which allow astronomers to have a better understanding of the physics of the Jovian atmosphere. Hubble observations of the turbulent clouds of Jupiter were used to help target close-up picture-taking by the Jupiter-orbiting Galileo probe. While hunting for volcanic plumes on Io, NASA's Hubble Space Telescope captured these images of the volatile moon sweeping across the giant face of Jupiter. Saturn's largest moon, Titan, is casting a shadow on the planet. The other moons appear white because of their bright, icy surfaces. 4 moons, from left to right, Mimas, Tethys, Janus, and Enceladus, are clustered around the edge of Saturn's rings on the right. 2 other moons appear in front of the ring plane. Prometheus is on the right edge, Pandora on the left. The rings also cast a shadow on Saturn because of the Sun's position above the ring plane. With Saturn's ring slightly tilted, the moon Dione casts a long, thin shadow across the whole ring system, due to the setting sun on the ring plane. The moon on the upper left of Saturn is Tethys. Though they look continuous from Earth, Saturn's rings are actually composed of innumerable small particles, each in an independent orbit. They range in size from a centimeter to several meters. A few kilometer-sized objects are also likely. Saturn's rings are extraordinarily thin. Though they're 250,000 kilometers or more in diameter, they're no more than 1.5 kilometers thick. Despite their impressive appearance, there's really very little material in the rings. Astronomers used Hubble telescope images taken from 1994 to 1998 to create a time-lapse animation that shows for the first time seasonal changes on the planet Uranus. Once considered one of the blander-looking planets, Uranus is now revealed as a dynamic world, with the brightest clouds in the outer solar system, and possessing a fragile ring system that wobbles like an unbalanced wagon wheel. The clouds are probably composed of methane crystals, which condense as warm bubbles of gas well up from deep in the atmosphere of Uranus. Hubble is also able to detect a wobble in the ring system, which is made up of billions of tiny pebbles. This wobble may be caused by Uranus's shape, which is like a slightly flattened globe, along with the gravitational tug from its many moons. Uranus is tilted completely over on its side, giving rise to extreme 20-year-long seasons and unusual weather. Neptune's unusual weather patterns also were the subject of a time-lapse rotation animation. Using Hubble telescope pictures, the animation shows that the planet has some of the strangest weather in the solar system. The telescope captured the most insightful images to date of a planet whose blustery weather, monster storms and equatorial winds of 900 miles per hour, bewilder scientists. Even the outermost planet in our solar system hasn't escaped the telescope's scrutiny. The Hubble telescope unveiled the never-before-seen surface of Pluto, which orbits at the dim outer reaches of the solar system, nearly 3 billion miles from the Sun. Pluto is two-thirds the size of the Earth's moon, but is 12,000 times farther away. Viewing surface detail is as difficult as trying to read the printing on a golf ball located 30 miles away.